Stefano runs the human reinforcement learning group at the École Superior in Paris, and he does some really fantastic work with an individual reinforcement learning, but also in social learning as well. So he's going to present some of this very current work, and we're really excited to have him. So please take the stage, Stefano.
Okay, so thank you very much, Charlie, for the introduction. And yeah, I really wanted to thank Charlie and Valtario for building this amazing meeting so far. So I hope I will not disappoint or reduce the quality of the speakers that has been already quite outstanding. Yeah, so as Charlie said, my work is mainly, so far at least, in private learning and decision making, private being without any social component, but we have a couple of studies published or ongoing on this topic, and this is what I'm going to talk today. Okay, so in the first part, we're going to have a more like a descriptive or empirical study, which wants to study, understand the computational mechanism underlying the imitation in the context of reinforcement learning. And the second part, which is more preliminary, it's more normative in the sense that we want to understand the property or maybe what is the, and let's say the best way to imitate. But we'll see that it's not an easy question and with no easy answer either. Okay, like for the first part. So very briefly, also because it's been nicely introduced by Wataru this morning, reinforcement learning is this idea that we shape our choice and preference based on the history of previous outcomes. Okay, so the very essence of reinforcement learning of private reinforcement learning is captured by the law of effect that says that the response that produces satisfaction tends to be repeated. Okay, typically it has been studied, for example, putting animal in boxes. They have to figure out how to exit. Okay, so this is, for example, Thorndike in animal intelligence in early 20th century. As we already seen, we often study this with bandits. Okay, so the idea is the subject is presented with different options, as we have been as experimental subject before. The value of this option is unknown. Typically, there is a good and a bad one. This is a very simple task in which one option is rewarded 70% of the time, the other one 20% of the time. And the typical results, not different from the learning curve that we generated previously, is something like that. So we have start a chance, then progressively the subject acquire a response to pick the most rewarding one. Okay. Let's say the standard model is something like this. Okay, we suppose the agent in an environment. The agent can produce action through a stochastic process, often implemented through a softmax rule. The action results in reward and punishment, and this is reward and punishment are then used to modify the belief about the value of the different options in that are called Q values. Okay. We know also a great deal about the neural correlates of these processes and the different variable of this model, namely the option values or the prediction errors that we're going to characterize a little bit later, seems to be encoded in neural networks that are very close overlapping to the reward network or affective network or saliency network that involve, for example, dopamine and the striatum, etc. Okay, but of course, especially as human, we do not rely only on private learning to essentially figure out what are the best options in our environment, but we also rely on observation, on imitation. Okay, so I think one of the main scholars that started investigating seriously social learning was Albert Bandura, that unfortunately died recently. And in this very influential paper, really formalized the idea that we can acquire bunch of behavioral modules just by observing others. So very famous was the Bobo dolls experiment, which basically what happened was something like that. So there was a demonstrator. The idea is that essentially there is a demonstrator, was an associate of the scientist that was beating the shit out of this doll, essentially, for a while. So with the kicking, etc. Yeah, all kind, not very mean. And then the idea that, with no instruction, a kid would present with the same doll, and you can see that the kid was reproducing that mean behavior of the demonstrator. So of course, this was on the context, understanding the roots of aggression. And it is also in the context of, this in the 70s was the peak of the popularity of Skinner and radical behaviorism, in which you were not supposed to acquire any behavior if not through reinforcement, okay? This was so this is the Bobo doll experiment. But you couldn't see actually because I had a YouTube video there. Okay, no, sorry, I will play it because it was nice. So Can you see the screen? Yeah. Okay, so this is the demonstrator beating the doll. Okay, so you can see, not very nice, that kicking and stuff. And the kid, suggestion, start beating the doll again. Okay, right. Okay, so how would you study such observational or imitation in reinforcement learning? With a simple adaptation of the two-armed bandit task. So this is a very popular example by Burke and collaborators. The idea is that you have observational trials in which you see another subject playing for two options, more or less as we have seen before. This is followed by a private trial in which you can make a choice, okay? In this original study, there were different conditions. So first condition is private learning in red, and then there were two social conditions, a condition in which the learner could see only the action of the demonstrator, which would be the pure observational learning condition, and one in which could be seen both the action and the outcome. I will not focus much on this. So you can see already in these learning curves that there is a modulation of the performance, right? So in this case, the demonstrator was having a high correct response rate, and this influenced the correct response rate of the learner. We studied also in our lab this design with this protocol. So after a training, the subject was asked to choose an avatar to represent themselves. Then it was paired with another avatar, which actually was a virtual subject, and we used always a neutral face. Then there was the learning task, as in Burke. And finally, we have, after learning, an evaluation of the perceived trustworthiness of the avatar. We used quite variable demonstrators by simulating different agents. So there were bad demonstrators with a very low accuracy and a good demonstrator with a higher accuracy. These are the performance of the real participants. So you can see in average a little bit lower the demonstrator. So what you can see replicating Burke is that whether or not you were paired with a good or a bad demonstrator affected performance, of course, specifically in the condition in which imitation or observational learning was allowed. Interestingly enough, the pairing with good or bad demonstrator also permeated the social judgment to the avatar. So again, understand that the face of the avatar was always the same for all participants, and an avatar whose face is usually ranked as being neutral. But then you can see if the performance were higher or lower. So there is a relationship between the judgment of trustworthiness and the actual, the performance of the site. So how much you benefit from observing this person. So what Burke and then others thought about modeling observation in this task is something like that. So this is quite complex. This is the simplest representation, and is a process that we can call decision biasing, okay? So here is the model as before. We have the Q values, then we have the selection process, the choice, the update. And the idea is that D is the demonstration, so the action of the participant, how it is integrated in this process. So according to decision biasing, it is actually biasing the selection process without modifying the values, okay? So they proposed this model, and they also proposed the neural correlates to support this model. They did fMRI experiment, and namely they found a dissociation between the social prediction error and the reward prediction error. Okay, and this is just a slide to say that this model is quite still popular. So for example, in influential reviews about social cognition and social learning, it has been cited and still cited as a reference model essentially in the field of imitation in the context of reinforcement learning. But when we started studying this question, we had maybe an alternative hypothesis. Okay, so our hypothesis was the one concerning mimetic desire. So was first formalized by a French philosopher René Girard, is the idea that we acquire our preferences essentially by observing the preference of the other, right? But then it becomes really our preferences. A good example is the kids that are fighting for the same toy in a room full of other toys. Or why? So everybody could have the same, nonetheless, they seem to fight for the same. And I had actually to an example of mimetic desire in rats, which I found quite interesting. I mean, clear. So here there are two rats, right? You can see them that are leaking for water in a cage, and they are kind of fighting for the same place. But then you move the camera, and you actually realize that there is another dispenser just a few centimeters across, and nonetheless they fight for the same. So it's really the kids that fight for the same. Why? Okay. anecdotes apart, beyond this anecdotal example, I also had the idea, because not me, but friends and collaborators in the lab where I did my PhD actually studied this, not in the context of reinforcement learning. So they have a very simple task in which essentially they showed items with and without manipulation by a subject, right? And then asked the ratings of these items to the participants. Across 5 experiments, they found that the objects that were manipulated, so they were the object of interest of another participant in the manipulation, received a higher valuation compared to the other one. And they also found like a neural model of this, which indicated that essentially the action of the other participant were encoded in the parietal premotor system, which is also the mirror neural system for those familiar with the neural basis of social cognition, causally influenced the rating through modulation of the reward system. This is the same system that was that I showed you essentially in the concerning the neural basis of reinforcement learning. Okay. So we designed essentially an implementation of this value-based system in which the action of the demonstrator, instead of just affecting the choice, it actually modifies the values of the learner. Okay. And we run several experiments in which we get rid of one of the conditions of the original book experiment, that is the one in which you can observe the action and the outcome of the other participant. So you can also only observe the action of the others. By the way, exactly as in the task that we just played, right, the first one. And we also modified different features. So for example, we didn't have a strict alternance of private and social trial, right? So we had interleaved several numbers of private and imitation trials, okay? So we have 3 conditions, more specifically the private one without social information. Then we have 2 social conditions in which you can observe a demonstrator. And sometimes the demonstrator was skilled, so it was picking the correct response 80% of the time. So it's someone that you should imitate. And sometimes the demonstrator was unskilled, so was picking the correct option only 20% of the time. So it's something you should not imitate him. We compare different models. I mean, the baseline model, we know imitation, the 2 main model, and also a more complex model-based imitation that I will not discuss much in this here. We verified that we could identify correctly this model in our task. It's something that is called model recovery. I trust the tutorial 3 will treat this topic, so I will not develop further, but it's an important step. And then this is where there is the model comparison results. So in the first experiment, they were actually quite not disappointing per se, but undecisive, right? So you will not, so here the model frequency or the exceedance probability, long story short, to quantify what is the most probable, most likely model in this experiment, in this population. So it seems to be like a bimodal between the no imitation model and the value shaping model. But in this first experiment, essentially the manipulation skilled, unskilled, so good but demonstrator, was done within subject. So we thought maybe it's for this reason. So what we did, and then we fitted the model separately in the unskilled and the skilled condition. And so you can see there is a sort of interaction. I mean, you should not take it like it's not like an interaction in a frequentist manner, but in the unskilled trial, the subjects were better explained by no imitation, right? Like they were switching off imitation because of the demonstrator sucking at the task. And in the skilled trial was clearly the value shaping model that was outperforming all the others. We then replicated this again, this time in a between subject manner. So we have a cohort of subjects that were always exposed to the unskilled and another cohort always exposed to the skilled, and you can see the same results. So when the imitation was useful, right? So the demonstrator was skilled, the value shaping process seemed to outperform, to better explain the data. So once that we have established what is the model, we can a little bit analyze essentially the model parameters. The model parameters that are important for us are the learning rate and the imitation rate. Okay, so the learning rate is how much I take into account essentially the reward, and is alpha p here is the private learning rate, and the imitation rate is how much I take into account the action of the other participant, right? So first results that we found and replicated in all experiments is that in general, the imitation rate is lower compared to the private learning rate, which makes sense because in a way, the action of the other participants is at best an approximation of something close to a reward, right? So you trust more your own information rather than information that comes to infer directly and indirectly from a model. And then we also analyzed the imitation rate in the two conditions of skills. So for unskilled and skilled demonstrator. And what we also found was an adaptive modulation of the imitation rate, which is basically in par with our model comparison results, according to which the imitation rate in the skilled condition was, of course, higher compared to the imitation rate in the unskilled condition. So when imitation is not adaptive, the imitation rate, the computational imitation rate is downregulated, okay? So we also look at a behavioral signature, discriminated these two models. And we leveraged on this fact that in this design, we didn't have a strict alternance between imitation trial, so demonstration, and private trial, right? As such, we could essentially test what we can call the accumulation of the demonstration, which is basically the impact of a demonstration at t-1 on a private choice at t+1, when in between two, there is another demonstration, okay? So the key idea here is that, especially if you take DB1 is the baseline decision biasing as it has been proposed by Burke, there is a decline, right? So the effect wash out after just one demonstration because there is no permanence. And there is no such decline in the data, and there is no such decline in the value shaping model. And then we can also study the propagation. Okay, so this is a case in which we have a demonstration, then two private trial. And is always the impact of the demonstration at t-1 to the private at t+1, when in between there is another private. So you can see again that in the case of, in this case, both decision biases model, there is a decline of the impact of the demonstration into the choice of the behavior, but there is not such decline in the data and in the value shaping model. So it seems that essentially the model seems to capture this more the fact that the effect of imitation is a little bit long lasting than just a bias in exploration, that is the decision bias would predict. We also wanted to replicate this data, in different setup, and we reanalyzed, thanks to Alexander and Giorgio, data that has been they were published in time, in which they used a different design. Okay, so they used a design in which this time was not like A and B, good and bad response, but we have what is called a restless bandit. Okay, so always two options, but the value of the two options drift, right? So an option that is good at the beginning, it became worse at some point, etc., etc. We also checked the recovery, and the model comparison results in the old data set also was consistent with the idea that value shaping outperform decision biasing. And what was also interesting here is that in this task, they gave sort of explicit cues about whether the demonstrator were actual subject had been tested before. In addition, with the task, they also recorded the IQ of the demonstrator, and then they split in high and low IQ, and they give or not this information to the learner in the subsequent experiment. And the result is that essentially being informed about the IQ of the demonstrators is a sort of external cue, modulate the imitation rate. I mean, unsurprisingly, if you are being told that the subject that you're going to observe is not high IQ, the imitation rate is lower. All right, so now you have seen in our data and also in other data that there is some sort of modulation of the imitation rate. And we wanted to capture this, so we proposed a meta-value shaping model in which we suppose the imitation rate, instead of being a fixed parameter, is something that evolves across time as a function of something. As a function of what? So we proposed a very simple, low-level meta-modulation, which just suppose that there is an increase in the imitation rate or a decrease as a function of whether or not the demonstrator picked an option that is what you believe is the currently higher viable option, right? So you start with a certain degree, and I'll explain it a little bit later better, but you start with a certain degree of trust into the demonstrator. But if at some point your preference and this preference or a preference diverge too much, you don't imitate, you reduce the imitation. Plugging this additional parameter, this additional module on the value shaping model, it provides a better explain. And then if you generate the theoretical learning rate and you analyze them, you find the significant modulation of learning, of imitation rates that we found in the data. Okay. So very quickly, I added recently whether or not these results generalize to other form of social learning, right? So we have seen imitation, but what about advice? So first of all, just a very quick distinction between imitation. The learner is active because has to forage for information, pay attention, and the source is kind of passive, right? So the demonstrator is not supposed to be strategically implicated in the process. Advice is different because in a way the learner is a little bit more passive, just receiving advice, while the source, which is now not called the demonstrator, but the advisor, is kind of active, okay? I could find that this first study, it has been cited also by Wataru, I think, in your slides, one of the first. So in this case, there was just one advice event. So after an advisor did the task, and after the task gave only one advice. And there is an impact in the learning curves. And then when they did the model comparison, the winning model was something that they called the ARC whatever outcome bonus. Anyway, something that's conceptually close to value shaping, while another that was called initial, or it was a sort of decision biasing, didn't perform as well. This distinction has also been studied by Yuri Ers, which is a friend and collaborator also working on this topic. By the way, also using a fishing metaphor seems to be very popular in people working in social reinforcement learning. Two different lakes, Lake Bagel and Lake Pacman, different amount of fish. And then there is at some point, so at the beginning, the participant is playing alone. Then at some point, the participant has the chance whether to, strictly observe the choice of someone else or to receive an advice by someone else. So these are the behavioral results. So you can see this is the green is the learning curve without social information. We know the pattern now, so negative acceleration, conversion to a certain degree of correct response, etc. The yellow and the red lines are the learning curves after either receiving an advice in yellow or an observation, so imitation in red. So you can see there is a spike in correct response rate. By the way, the advisor is 100% correct, right? Or the demonstrator after the response. And then there is also a long-lasting effect. There is also an interesting effect in reaction times, people being more slow the second trial after the observation would go. So in the imitation case, it goes with the idea that imitation is more cognitively demanding. So the imitator is active rather than passive in that case. And the better model is a model that essentially has two different features. Well, a Q boost, it is again a form of value shaping, plus also a more long-lasting modulation on in the gain function in the temperature. Okay, so what I've seen, we have seen so far, our main finding is that imitation can be understood as a modification of value rather than biases. Okay, so it has been replicated in 3 experiments, 2 from our lab and then another, but also generalized maybe to other forms of social influence, such as advice. And the second finding is that, of course, imitation is not blind. This has been already postulated by evolutionary biology, etc. So one should imitate in a way that is critical somehow. And this we found trace of this simulation. But we have also proposed, and this is maybe a little bit a provocation for Natalia, right? So that she wrote a nice paper to say that imitations will be mindful, but we find a very parsimonious, very behavioristic, simple way of modulating the imitation that actually it's still a good explanation of the data. But I mean, of course, this is just for the debate rather to being a final opinion. Okay, so let's move to the second part, which is more about understanding in simulation experiment the properties. Why? So yeah, we have found that value shaping explains the data better. Okay, so it has a certain descriptive accuracy. Yes, I can just comment on the amount of design that have been tested for, which there is some diversity, but of course it's already very limited, as you noted. And I think we will also come back to this idea. So actually, I will add that there is another limitation in my designs that it is not in what Wataru showed, is that imitation is not bidirectional, right? So it seems like there are 2 different sources of information you suggest. I don't know. So could be, I mean, of course, to some extent, all these results depend on the design. And also, we will see in the simulation, we will also show that the performance of the model are crucially dependent on what are the setup of the task. I think, yeah, long story short is more work is needed to understand for me the exciting part, under which circumstances one can shift between the two modes. But yeah, maybe later you can show me more what is your design and we can think about it together. Yeah, so why is the second part? And by the way, in the second part, we'll also, so we want to verify a little bit whether value shaping is better than decision biasing, which is like a simple way to just try to see, produce higher performance, which is something that is not necessarily linked to being having higher descriptive accuracy. And then, of course, I mean, this question is not possible whether or not it's better, is rather under which circumstances. So we will tweak different parameters of the task to see, also to relax precisely some assumption about the performance of the demonstrator, of the task, etc. And therefore, maybe, hopefully this can help us understand the properties, but also generate a new experiment to further challenge it. Okay, so these are the different scenarios that we have been tested. So they actually 6 scenarios, but I don't know why I numbered in this weird way. In my mind, there was more logical. Okay, so anyway, so what are the variables that we are going to manipulate? First of all is the contingency or the difficulty of the task, okay? So the experiment that we run, the contingency or the difficulty was like the correct response was rewarded at 65% of the time, and the wrong response 35%, and punished otherwise, right? Again, this is a choice, it's in between easy and difficult. What we've done in the experiment, when essentially it's market range, we actually spanned a lot of level of difficulty from very difficult task, 55-45, which essentially the difference in value between the two options is very small, to super easy task, 95-5. The second thing is precisely concern the demonstration. So in the paper, we used 80% correct response. We will relax this assumption in 2 ways. So in one case, we will have still learned the demonstrator. So demonstrator with flat accuracy over time, except we will not only have 80%. We will span from randomness to 100% of correct response, so more or less. Okay. In yet another scenario, which is called the dynamic, we will have essentially naive demonstrator, which is the condition of essentially the task that Wataru showed us. So everybody has to learn in the same time. We also manipulated the volatility of the task. So stable is the standard version in which A is better than B all over the place, while at some point we could have a reversal, right? A change, so A become worse than B. And finally, we also manipulated the directionality, right? So in the standard experiment, we work with unidirectional imitation, right? We wanted to see how the performance were affected if we implemented the bidirectional imitation, in which the imitator and the demonstrator basically take the same role, essentially. So we have already seen the model. So the basic model is this implementation of the Q-learning for these simple bandits. Okay, so there is an update step on the chosen option and a stochastic decision. This is again a decision biasing. So you suppose that the probability of choosing D, so the action that's been chosen by the demonstrator, is modulated by a certain factor. And then this is the update for the value shaping. Okay, so this is already what I showed you. We start with the Najar configuration, the one that we already published. So these are the performance of the basic subject with no imitation. And now what you can see in the other graph, the dotted line is the performance without imitation, and the bold line is the performance of the model, right? So you can see in that case that, so this is very close to the task, is that essentially both imitation model outperform the non-imitation model, and imitation, the value shaping imitation seems to be even better than the decision biasing imitation, right? We stopped the simulation of 20 trials because it's the number of trials that we had in the task, but it is true that the trend of the learning curves maybe indicate that in the long term, the ranking of the two models. But again, here we tested a very narrow parameter space. So the task was very particular. The demonstrator was 80% correct, etc. Okay. We wanted to see also, so looking at the parameter space, so this is first of all for the no imitation model, the performance as a function of the two parameters of the agent, the temperature and the learning rate. Since we are working with a very stable task, essentially the choice temperature actually is not 1, but is close to the max that we used in the simulation, and the learning rate should be quite small, right? So you can see this is a pretty standard landscape of performance in this kind of bandits. So now if you look the contrast between the two imitation model, the decision biasing model and the value shaping model compared to the no imitation, you can see that you have more red or yellow. So the imitation model outperforms the no imitation model precisely when the simulated agents is in this area of the space in which learning rate and the temperature are not optimal, right? So this is maybe a trivial result, but it's just a way to illustrate what is going on in that case. Right, so now what we tried is that instead of fixing the parameter of the simulation to the very specific parameters that we use in the experiment, we're gonna use a broad range of demonstrator performance and also a broad range of task difficulties, okay? So it's gonna be the same, so first is the no imitation, but now let's see what happens with the two imitation model. So now you can see that if you broaden a little bit the space of the parameter explored, decision biasing imitation, that's at least the way that we implemented it, is not so great anymore. It's actually a little bit lower than non-imitation, while on the other side, the value shaping imitation is in average better. Not the plateau, but it allows a faster acquisition of the correct response. Let's unpack a little bit these results because you may think it's weird that decision biasing imitation is not good. So what we do is that, first of all, we plot the performance of the three models as a function of the task difficulty, or task easiness. So the value difference is the difference between A and B. The higher, the easier the task, okay? So you can see that already in the absence of imitation is a monotonic function of the difficulty, right? The task being easiest, the correct response rate of the subject is higher. So now you can plot the performance of the two imitation model again on the top of the no imitation model. So what you can see in general is that a first take-home message, which is maybe expected, is this one, is that imitation is good when the task is difficult, right? So when the task is difficult, this is the place where you will benefit of social information, and this is true for actually both decision biasing and value shaping. The difference between these two is that value shaping seems to be a little bit more robust, right? So the crossing point between the two curves occurs at a level of difficulty that is lower compared to the other one. So it's more resilient, you can say. The other thing that we can do is now we plot the performance of the model as a function of the skills of the demonstrator. Of course, so it's flat for the no imitation because there is no, and so you can see again that the performance of the imitation model, unsurprisingly, are a monotonic function of the skill of the demonstrator. But you can also see again that it's more a matter of value shaping being a little bit more resilient, right? So the advantage starts before the one for the decision biasing model. Now we wanted to move in a case in which we have not like a informational asymmetry between the demonstrator and the learner, right? So here we're supposing the demonstrator has already learned the task and already picked with a certain probability the correct response. What happens is actually the demonstrator is learning the task in parallel as the learner, okay? Well, when we do that, we observe the following pattern. So first of all, essentially the benefit of imitation becomes much more reduced, right? So if me and you, we start a gut together, there seems to be not a huge advantage. Now it's interesting that we have seen what was happening in the case that Wataru showed us before, because I think we all have the impression we benefit greatly from imitation. And I didn't run the simulation, but my intuition is that why in that case it worked, because it was actually not only two participants, and it created a wisdom of the crowd situation in which everybody could sample different options. But at least with the parameter that I am using, there is not such a huge advantage. And again, since now the demonstrator is no more just characterized by one parameter, but actually by a learning rate and a temperature, you can see what is for which value of the parameters of the demonstrator there is a benefit or not. And first of all, you can see, for example, focus on this graph, that the maximum of being, the advantage of the comparison between value shaping imitation and no imitation, it occurs when the demonstrator has a learning rate that is optimal for the task at hand, unsurprisingly, which is close to the value that I showed before, essentially 0.1, 0.2. And similarly for the temperature, right? So the advantage that the imitation simulation has over the private simulation, when the temperature of the demonstrator is too stochastic and not very well adapted to the task, is actually negative, and then it becomes positive. Okay, so now we had the third, another characteristic, that is we try to have a bidirectionality, right? So we are now both naive, me and the demonstrator, and we are learning the task together, exactly, and we can observe each other. We observe even a decline of the benefit of imitation under this case. So actually, this is not the case that we were playing before with Bataro, because there was actually multi-directionality. And again, I think the reason is because in one case, there was more than one subject and more than one option. So again, it's an example in which the structure of the task very, very important. On the top of that, we wanted to see whether meta learning, so the adaptive modulation of the imitation rate, was useful. So essentially, I will unpack a little bit what I already explained together. So the idea is that the imitation rate is updated as a function of whether or not the demonstrator has chosen what you concurrently think is the best option, right? And it is set to go to 0, essentially, if it's not the same, and to converge to the private learning rate if it is the same, under the assumption that the higher learning rate the agent can have is his own private learning rate, which it is an assumption that can be discussed. So when we had this meta learning, we demonstrate that indeed it increased performance of the imitation setup compared to the imitation setup. And it does so a little, so it preserves also the ranking, the general ranking that we are experienced so far, that is value shaping being better than decision biasing. So just to see whether or not this meta learning model is working, here I'm plotting the learning rate, so the imitation rate in different, essentially, pairing of type of subject. And the blue line is the case in which both you and both participants, because actually remember that in that case, there is no strict distinction between demonstrator and imitator. When both are high performer, the imitation rate is higher. When they are lower level of performance, it is significantly lower. Now, the question still can be asked whether this meta learning process can be minimally or even maximally improved. For minimally would be maybe to modify the convergence parameters, because in that case you can see that even when both you suck, there is still an increase in the imitation rate, which is a little bit surprising. Right. On the other side, could be maximally improved, maybe to have more explicit Bayesian, theory of mind implementation of the process. Right. Now, as for the final manipulation, I guess, what we now implemented is an instability in the environment, right? So now it's no more the case that the option A is always good, but at some point there is a reversal, right? And we are keeping all the features that we introduced so far. So the demonstrator is also dynamic, there is bidirectional, this is meta learning. These are the performance of the imitation. So this is essentially the accuracy up to the reversal point. This is in the middle. So essentially is the probability of choosing the initially correct response. So you can see that after the reversal, the shift, the probability decrease, right? And now these are the performance of the model. So what you can see here now is for the first time. So the first part is as the simulation that I just showed you before. So the decision biasing is better than no imitation. Value shaping is also better than decision biasing. But critically now, after the reversal, the performance of value shaping are basically catastrophic, right? So they didn't manage to reverse an option. And I think it's a kind of a form of polarization, in a sense in which you and the other, you are basically creating an overestimation of what is the correct response, which is beneficial during the first phase, but you pay it once you have to revise this. And since we are still observing each other, we still think, hey, that's A is great. Yeah, it's great, great. So, instead of paying attention to the feedback. because according to the model, and as we mentioned in the title, essentially the action of the other acts as pseudo reward that complement the absence of reward induced by the changing contingencies. So our main finding, it's of course, I mean, this kind of simulation study, it's hard to say when we stop and when we start. There are a lot of parameters can be tweaked, but at least we try to start with something that was quite close to the task that we used. The key finding, I would say, is that first of all, of course, the optimality of an imitation model strictly depends on the task, which can be seen as the environment or the context of the ecology. So what is the problem at hand, right? In conditions that are close to the ones that's been used during the in the experiments, value shaping seems to be generally better, more or less for this kind of reason, right? So in this kind of models, there is two things, right? So there is the knowledge, that is the Q values, whether or not they converge to the true Q values. So it could be sort of epistemic accuracy. And then there is the performance. So whether or not the model take the good action. We can call it the instrumental or praxic accuracy, right? Do the good thing. So on the good side, the decision biasing will not deform, will not modify, will not create distortion on your values. So it could be, for example, useful whenever you have to communicate your Q values for any reason, etc. On the other side, at least in the simulation that we've seen, is never too great. It's never too bad, but it's never too great. Value shaping, the way we implemented it, but it could be improved, it is epistemically inaccurate because it creates distortion in the representation of value, because essentially each time that you pick A, I think that is a reward, etc. And on the other side, depending on the context, it can actually be sometimes good, sometimes very good, sometimes very bad. So yeah, this is the conclusion. Then what are the open questions? There are many of them, right? So first of all, there are infinite alternative formulations that have been tested, including, of course, mindful implementation of it, but also hybrid version of it, right? So could be that for me, for example, something could be fascinating is to see whether across development we observe, I would predict a shift from value basing to decision biasing, right? So when you're a kid, you are more in a situation in which there is an asymmetry between the demonstrator being good and you know nothing, and you have to acquire the value. And maybe later when you are more experienced at the meta level, you switch to decision biasing, right? Even within a subject today, or based on the task, there could be a rational adaptation, right? So a model that arbitrates between different implementation. And of course, there is the importance, and is linked to the question received, to test a more complex scenario with multiple options, multi-step decision making, etc., etc. Okay, and with the bells, I think I'm pointing to the fact that my time is over. Thank the team. I mean, it was Alice and Anis, former postdoc in the study that I presented, but of course, yeah, all team contributes in its own form. And yeah, so this is actually not our lab, but this is the view from the entrance of our lab. Come and visit us in Paris. We'll be happy. Thank you very much.